So I welcome to our talk, Optimizing Performance in Large-Scale React and Node Applications. So I'll quickly introduce myself. So my name is Tejas Gavankar. I'm from India. I work in Red Hat as an associate software engineer. I'll also like to introduce my brother and my co-speaker, Hrithik Gavankar. He also works in Red Hat. He's a software engineer. So let's start with our talk. So, just start before beginning, how many of you all are web developers or have worked in React? Oh, nice. So we will all relate to this slide. So initially, when we launch a website, when we put all the hard work of days and nights, when we, next day we have a launch, and just before the day we, fix some fast bug fixes. It's really hectic. And when our app launches, that's one of the best days of our life. So if you see, when we launch a website, we feel really happy. Okay. So after a few time, if our app is serving a lot of users, so then performance kicks in. Usually for first 10,000 users, the performance is fine. But when our app goes to maybe say 1 lakh users, so there we face some issues related to performance. So in this whole presentation, we'll look at we'll break the whole presentation first. What is performance? What really performance we should look at? And we have taken the most common technologies, React and Node.js. And let's look what we can do in the best way to give a performant website and all our users are happy. Okay, so I'll start with what performance actually is. So if you look in the graph, so the horizontal axis is the number of concurrent users, the vertical axis is the load time in seconds. So for the blue line, let's assume the scenario is 1 server, 1 user. Definitely, if you do that, you will always load a performant website. Let's look at the next scenario. So here you have 1 server, which is loading for a lot of users in real world time. That's the real world time scenario. So if you see, as the performance, as the users, the traffic on a website increases, even the load times take large. And at peak traffic times, it's like it takes a lot of load times for most of the websites. So what this tells us, performance is not just a single metric. It's a whole framework in which we see how the users are able to load their sites, and also we should take care of how the users' experiences, all the click events, all the functions, or all the rendering of images and your JSON data. All this together is what performance is. So the second thing which is really important when we talk about performance and loading our websites, what is a load? So if you see, it's just a flow chart here, and it marks all the important points in the web browser. So first we have the paint, we get the content served, the window is loaded. It's interactive, and the ongoing UX forever. So I'm just, it's an umbrella in which I am trying to point out that the users will use any functionality of your web app. So what I want to point out here is performance is not just a window load. Is the whole experience that the users see. So let's take an example over here. So in the left you see both are the same websites, just 2 different scenarios. So both websites take nearly 4 seconds to load, but if you see the experience, it's a bit different. In the left, whole website does load directly in the 4 seconds. So like till the first 4 seconds, the user will see a blank page, and at an instant, the user will see the whole website. In the second experience, to the right side, you see the web page, it doesn't load fully on the first render. It takes 1 second for the navbar, 2 seconds for the hero, 3 seconds for the form, and 4 seconds for the search and everything. So it gives a very different experience to the user. So that's what we are trying to do. Okay, we talk about performance, load, and how different they are. So this points us towards 4 key experiences that we should all, aim to solve, or we should keep in mind. The first one is it happening? So if you see on your website, you just landed on your website, you're using the nav bar, you're using a form, you're using a click event. Is it happening? That experience matters. Second, is it useful? So on your website, we can have different websites, pointing different motivations. One can be a shopping, second can be an educational website, third can be a banking website. So with respect to your website, do you have the useful content which is required for your specific needs? Do you have that rendered first? Because that's what users are going to see. The third is it usable? Whatever you render, is it usable? Is the event clicking on? Is the JavaScript running? And the fourth, is it delightful? Are your interactions smooth enough? Is the whole experience very user-friendly to the user? Is your JavaScript not blocking the main thread of the web browser? So all these things matters. So let's move more towards the largest content painful and all the Chrome Lighthouse things. Hrithik will take over.
So hi guys, very well morning to everyone. So I will be continuing from here. So as the title suggests, first impression counts. So as it is said, your first impression is your last impression. So as Tejas gave a brief like about what exactly you are focusing on user experience, and so I'll try to touch exactly what we need to consider. What are the exact metrics we need to consider for this user experience? So as the title suggests, fast load. It focuses on how quickly your website is loading. Now let's consider a scenario like me as a user or you people as a user visit a website and the website is loading slowly. It is taking time to load. Second is like the website has some glitches. You're trying to click a button, you're trying to search something, but it's kind of delays what you see on a website. So what we will do is jump to some other website which is quick and fast enough, which gives users a good experience in spite of this lagging website. So now let's switch this scenario. So consider yourself as a developer who has made this website and who is now facing issues of not getting users because of the slow loading and glitches on the website. So this scenario is like a lost opportunity, a loss of revenue, and a loss of trust from the people. So here the first fast load comes into the picture. So Google also like pushes your SEO if your website loads fast. So it's one of the key factors like we should consider primarily before for good SEO as well. So the three metrics on which this is decided is LCP, that's longest content paint, FID, that's first input delay, and CLS is cumulative layout shift. So I'll explain into depth all these three in our next upcoming slides. So yeah, largest contentful paint, LCP. So as this name suggests, it focuses on the loading performance of a website. So these are the bars or the standards which are set. If your website is like if the loading is done within 2.5 seconds, it has a good score. And if it's anything more than 4 seconds, it's your loading is it's poor in performance. So like what exactly you could do to improve your LCP? Focus on having the content as much as smaller in size, like easily available. You could make use of CDNs, CDN links, servers. Also your images, videos on the websites could be in form of WebP and kind of stuff. And this is all will help you to find out this LCP will push to a good banner. Also using some script async, script defer, focusing on the loading, like having some preload, also keys what we have right now in modern browsers, what they support. So this is all could help you to get a good score in LCP. Second is the first input delay. This focuses on the interactivity performance, like while the user is trying to click a button and if the page is unresponsive, it's clearly showing that your JavaScript is blocking. It's blocking the main thread. So what you need to focus is on making your JavaScript executable in less time as much as possible. So here you could remove unusable code, break down your code into like more abstract it down, and having make use of React lazy load comes into the picture, then web workers. So like such parties like libraries you could use, and you could just get on the good bar that is like less than 100 ms, what FID focuses on. And the third one is cumulative layout shift, that's visual stability. Consider now this focuses on after your website is loaded. After the website loaded, are the content on the website in the same position where it were on while it was loaded, or they are just moving here and there? So for this, I would like to give you an example. Consider you have a website over there and you wanted to click on a button, but at the same moment you try to click a button, a dynamic ad pops up and you by mistakenly click on the ad. So this is where CLS is coming into the picture right now. So here what the main thing you should always focus is on, always give a fixed width and height for your content that is on the website, image or video. And if you already know if there are some dynamic content to be loaded on the website, you pre-handedly give a, like the division should be very strict with the height and width, so that it does not later messes up with all the around components around it. So that's the primary thing what you focus in CLS, and anything beyond 0.1 gives you a good score in CLS. So as we talked about the metrics, so what are the tools available so that you could get to figure out on your own website? So the first basic tool what I found on Chrome extension was it's Web Vitals. It's a Chrome extension, it's available. So here I have just used a website, and you could just have it in your Chrome extension and enable the console logging for the extension. As you go to your website and just perform some actions, your browser console just logs all the scores for LCP, FCP, and CLS. The great thing is that along with the score, it also provides you with the component that is responsible or that has the highest impact for the score, for the responsible score. And Web Vitals has a drawback that it is not good for websites that have like large pages or large content or n number of routes. So like single page applications or small websites, Web Vitals you will consider. To overcome this single like this big websites, so there is another tool that is Unlighthouse. This is an open source tool. It is like Lighthouse combined with Web Vitals, you could say, and this has 4 parameters on what it focuses. It gives you the performance, accessibility, best practices, and SEO score, and it's the perfect for large scale. I'll quickly show you. I have a report generated with Unlighthouse, and you could see like this is for a website called as fireship.io. This is the performance metrics what I've received. This is the score. Where is it? Like what's the LCP, CLS, everything I could get. I also can. It's also making me available the tree map. So this is a kind of the tree map of my website, and you could just see the space, the transfer bytes, everything just painted on the browser. This is a score for accessibility, how the website is accessible, along with all inputs which component you could improve on. The second is best practices like cookies management and everything. It also detects and gives you a good score. And this is also the SEO what it throws on, and so it's good into SEO. Yeah, so this was regarding Lighthouse. So yeah, the next topic we will be jumping towards the technology React, and so Tejas would be continuing with that. Thank you.
Hey, hi, back. So great, thanks for giving us an insight about how we can use browser DevTools for all the optimizations and performance things. So let's start with React optimizations that will make a difference. React itself is a very vast topic to cover. So we have created few, I'll say most common scenarios that we would all run into. We must have faced in. So let's start with if we have a very large JSON file in a web app, and we don't know anyway, we just have to render it. And let's add one more point to that. We have to render it on a home page, which is a very crucial thing. So what are the ways, or what is the best way, I'll say, we can do it in React? So I'll just move towards my Visual Studio Code. This time, okay. So we created like, you know, a dummy, we'll say a football app, just for, you know, creating the scenarios. So let's say this is our home page, and I'll just refresh it. Okay, so this is our home page, and we want to website a whole data of football data, in which we have players, their scores, their goals, and everything. And this is our home page. So what's the best way to do it? I'll quickly move to my code editor. So this is our home page. So the reason, if you know, I just do it directly, just call the component. So the component that I'm using is football database.tsx. So if I call the component directly on the home page, it's a bit risk. The risk is you have a very large JSON file. Definitely we will use pagination, but even we are showing at least 100 records at a time. And since it's on the home page, we don't want to, you know, adapt to a risk. So what's the ideal way or the best way to do it? So in React, we have, you know, the functionality of lazy loading things. So if you see here what I did for the home page, the whole component football database.tsx, the APIs get called here. So I have just locally created an API. If you see here, we call it on the use effect on the page load, and while using it on the home page, I lazy load it, so that it loads lazily and doesn't affects any other components on the home page. And after that, what we need to do is just use a suspend component fragment. We can add a fallback to it and just load the whole component, the football database, in that. So what this helps us in, you know, the cumulative layout set that Hrithik was talking about. All these things are not affected. And if you see the website, these are nearly 100 records, and all of them load very nicely. So this is one of the, you know, scenarios using React Lazy and Suspense we can use for loading large JSON files. The second one, this was just the video. Not everything requires a re-render. So in React, definitely it's a plus point if you say we get re-rendering very fast. But in some places, for example, let's move to our website again. So I just created a celebrations, you know, route. So here, if you see on the home page, if you just click on the celebrate goal, you get a confetti. I haven't added the animation because it will be too much. So when you just, you know, click on this, the sum adds up to the confetti. But here is one more, you know, thing that I have added, total goals. It's 100. So this is a different component, the confetti and the total goals, and this is the parent component. So every time I select a celebrate goal, the props pass to the child component, which is over here, and all of the functions, I'll just quickly show you even the functions for this. The total goals, which is over here, correct? This one, calculate total goals. It gets unnecessarily called every time. Also, I can show you this. When I don't use memo, and I click on the celebrate goals, every time this total goals, you know, the field is getting recalculated, which is not a nice thing, I'll say. So how do we, you know, mitigate the issue or use a different solution which is more effective? So if I use with use memo and, you know, just celebrate the goal again, this doesn't get calculated because the way it's written, it's over here. Yeah. So it's like a use memo. It's from React itself. You just need to import it, and you need the to, you know, just call the functions, and whatever the result that you get from the functions, it gets always stored in the use memo until and unless you refresh the whole website. So this will be a very performant thing, rather than doing this, because if you don't use without use memo and just call the functions, it always calculates this whole thing. Yeah. So these were second, and the third one, which I'll quickly finish, is we need to use cleanups in use effect. The reason being is, I just took an example over here. So I'm just adding a dependency config count and using the use effect. So every time we do this, the window loads and we are adding on event listeners. So we just need to write it this way. We will add a return statement so that whatever function that you have written gets cleaned up. And so this saves memory, and it, just for debugging purpose, it helps a lot to us. I think continue.
So hi, so as he mentioned about the React performance using your hooks and all. So other than that, I would also love to add like how the performance can be monitored. For every time you cannot go into React hooks and console log this hook was rendered on my website, like just logging the hooks, it was rendered so much times. So React Profiler is a again an extension within the React DevTools. It's present, and it gives you a brief like explanation on how each component is being rendered whenever the props are passed, and how much time your component is rendered, or what time and memory does it take. So this is one of the cool feature that's available in React Profiler. This is a kind of the graph what it shows for a for a website what I've been loading. So I'll quickly show another demo using the same website using the CLS part and React Profiler. This is how the profiler works. I'm recording it, and if I stop the recording, yeah, this is how this is called a flame graph, which gives you an overall graph of how the website was loaded. This is a ranked, which gives you how it rendered, how much times it has been rendered, and what time it has been rendered. These are the graphs available. As longer the graph, the longer time it has taken. Like this, all inputs help you to kind of like implement where and how you could optimize your web application. A very good example I will just quickly give you is using use memo. I'll celebrate the call as 5 times, and without use memo, I'll make it 5 times. I will observe now what it has recorded. So you could observe like it has recorded the time using use memo. It is lesser than 1.6 is the max what it has gone. And without use memo, you could see the time which is like gone up to 3.3 ms. So like this is how it's helpful, the React Profiler. And yeah, so that was a quick insight. Other than this, and also like this is a kind of my personal experience, and a kind of like grid, AG grid what I've used. There are many tables like HTML tables and React tables available into the market. But what AG grid is always, it's super easy to use in less code. It could handle many or like highly nested objects, and even the data that changes frequency. It might be stocks, it might be player statistics, and like team statistics. I have been using it with some NBA data into my past, and it's really superb, and it's feature rich, like sorting you can just move the columns easily, drag and drop with no amount of code, almost just pass a key, and it's very user friendly. So yeah, our next main topic is Node.js, which will be taken by starting by Tejas.
Hey, hi guys. Okay, so enough with the front-end frameworks. Let's move to Node.js. So what are the ways in which we can make Node.js faster? I'll quickly give a very basic idea of Node.js just for everyone. So Node.js is a JavaScript runtime where we can run JavaScript, and we use it mostly on the server side for running our websites. So these are few async functions, async and sync. Sync is usually we just in an event loop. The code runs in the very first, and it runs synchronously. Async is like we can delay it in a very simple and limit. So we can just delay the functions. So these are few async functions: set timeout, set interval, set immediate, next, check, promise. We'll look more into this in the next slide when we will understand event loop, and that's where we are. Okay, so the Node.js event loop. So usually when we run JavaScript, it creates a single thread, and we have an event loop attached to the single thread. So whatever the functions that we saw here, back here, async functions, I'll just give it brief description from here. So whenever we start a website, the start app.js, for example, all the sync code or the synchronous code that we have written gets executed first. And these are the 5 phases in which we define event loop. Node.js actually uses a lot of phases, but these are mostly the phases in which we will end up on. The phase 1 are the timers. So if you see in this, the set timeout and set interval, these functions execute over there. The phase 2 is the IO logic, the callbacks that you write in Node.js. Phase 3 is polling. Polling is usually the network request that your server handles. And phase 4 is the check. So the check is the set, immediate, next tick. So for all these, we have the check phase, and phase 5 is the close phase. It's like the end of your app. End of your app, as in if you want to app.close, or if you have any socket, you close that socket. So these are the 5 phases in which event loop we can define. So if you look at the execution, the set timeout and set intervals, though they are in phase 1, the phase 4 check, I told we use set timeout, set immediate over there. Set immediate, promise, these all run as a micro task queue. So they will always run first, then set timeout and set interval. This is like a basic event loop examples and how the functions run. So with respect to this, we have some safe coding practices. So in Node.js, usually you can, for importing models, you can create handlers and import whatever models you want. One good performant thing will be executing the imports at the root level. The second thing is we need to avoid expensive JSON operations and console.log. So a different performant thing that we can do is you can use some Winston loggers. So they do the logging thing asynchronously. That's it. And the third is, if you want to handle any async tasks in your Node.js server, use set immediate, set timeout. Then offload heavy tasks to worker threads. Don't block the main thread. Because of that, the whole server gets, it start lagging. And the fifth is prioritize polling phase whenever possible. So it's like we need to handle the request in such a way that we are not blocking the main thread and also serving the necessary functions to the whatever the API calls that we make. Cool. So I'll pass it over to Hrithik for the last thing, scale and manage Node.
So yeah, hey guys, Node, coming to Node itself is a single threaded by default, you all know, but it also has brilliant, like as an event loop, asynchronous also it could handle. So coming to the concurrency and parallelism part, concurrency is by default achieved, but in the parallelism part, what you come across, there are like processes like you could achieve parallelism. First one what you come across is child process in Node.js. So here in child process, like what happens is each node like gives a, like you have a child maintains a different childs which handle the processes. It's always like it spawns new OS processes such as file handling and running any command or script, and this is all done through the child process in Node.js. Each process has its own memory into this, and it is like great for CPU heavy tasks without blocking the main task, and it is good for parallelism, but it's not good for some app scaling and part. Just for running some scripts and commands, this is one of the basic available thing in Node.js, which is inbuilt in Node.js. Second, what I would love to come across is the cluster model in Node.js. It's one of the highly used in Node.js. Consider you have a node server and you have like one user for the server, like it's performing brilliantly for this 1 or 2 users. What if the users scale to like 1,000, 2,000 million users, but in that moment your node servers might fail, making it to some highly like 100% memory usage and all. So here the cluster model in Node.js is like what you could use. It's an inbuilt Node.js module that is built on top of the child processes, and each worker process has its own memory even, and you could say like it's excellent for scaling Node.js servers, like websites and HTTP servers is what it focuses on. And this is like how you could like make a server like cluster, like it's an inbuilt Node.js. And if I try to just replicate a Node.js process on my laptop, you could just have like, since my laptop is a 12 core CPU, so that's the number of CPUs I have, and that's the number of CPUs servers I could have initiated. Even if the port is same, if I try to hit the same server from different tabs on a browser, every time it throws a different PID, that's a process ID, that shows like how like it's handling it using my different ports. So yeah, and the last one is the worker threads in Node.js. Since you could have achieved like kind of multi-threading like to some extent into cluster and child processes, but if you need more granular multi-threading in Node.js, this is where the worker threads come into the picture. This is for very high CPU intensive computation and like task. This is one of the best thing to handle parallel operations in Node.js, and it's good for multi-threading as well as parallel computation. It's CPU intensive. It is very CPU intensive, and it does not has its own memory. It makes use of its parent memory using a shared array buffer. And yeah, I think this we have covered these three of the processes responsible for parallelism and Node.js. This is how we could achieve. So yeah.
Yeah, so if any questions.
Open for Q&As, yeah.
Is there a difference between JavaScript and TypeScript performance?
Could you repeat the question?
If there is a different speed to programming in JavaScript or TypeScript?
As of just the JavaScript TypeScript, it's like the question was, is there a speed difference in execution of JavaScript and TypeScript? So technically we were working with like Node, like it had it's again on event loop, it has the same speed, it's executed at the same speed. It just depends on the server what to include. If it's a node, if it's a bun, like if you let's switch the servers, that will have an impact on the execution speed.
Yeah, so I'll just add few things. So TypeScript is usually run in compile time, so it won't make a difference. It will be almost the same.
I hope that answers your question. Thank you.
Yeah, sure.
Where do the numbers for these indicators come from? Like the 2 seconds and 4 seconds, where do you start from big companies, or are they just like, yeah, 2 seconds is fast? Where do they come from?
I'll repeat the question. So the question was, where does this seconds and as he said, like where does this metrics come from? Considering the LCPs and the first add just the longest content paint, the FIDs and the layout cumulative shift, all these are SEO directives, and Google is one of the contributor and maintainer of this bars which are already set, the 0.2 seconds, the 0.1 seconds. So like there is some of the other body which is maintaining such like operations. Since Google is one of the most used search engine, so it's right now dominating into that numbers. Thank you. Questions?
Cool.
Thank you.
Yeah, thanks.